Welcome everyone at another Wood Lab session by Data Roots. They will have a session by Alexandre Carrier on how a data scientist could do data engineering too. He'll explain you how, in the context of a data lake, a data engineer has to set up data pipelines, and this is something that is needed for a lot of data science projects. And at Alexander's current project, I created a small framework to make it easier for data scientists as well to set up very simple data pipelines. If you have any questions during the session, you'll have the time at the end of the session to discuss any questions that you might have. So, Alexander, the floor is yours. You're still muted.
I don't know if you can see me. I'm going to share my screen. Okay. So hello everybody. So like Sam said, I'm going to present you a small framework that we created for a project that we have at DataRoot.
So we can't see your screen yet, Alexander.
Sorry, what?
We can't see your screen yet.
Ah, wait. Okay. How about now?
Yeah, now it's working.
Okay. Yeah, sorry for that. So yeah, the title of the presentation is how data scientists can do data engineering too. So basically, to give you a small introduction, I'm gonna explain where we work for that project. So basically, we work for VRT, which is the public radio and television company in Belgium. So it's actually the, let's say, Dutch version. As some of you may know, in Belgium, we have the French-speaking part and Dutch-speaking part. So VRT is Vlaams Radio en Televisie Omroep Organisatie. So this is just a little diagram to show you the different brands that they have. So there is some radio like M&M Stubru. There is some television, VRT News, Sportza. Sportza is for the sports. Ketnet is more for the kids. So we have all kind of different brands, and what we're building is basically a data lake where we gather all those different information together and start analyzing this data. So the way we work at VRT is that we decided to go with use case oriented data lake. So basically business comes up with a use case where they need some insight on data. And from there, we find that data internally in the different brands of VRT. We merge that data together into the data lake, and then we start analyzing the data through different tools. So the cloud provider that is default at VRT is AWS. So most of the tool I will talk about are AWS based. So later, if you have questions about tools, don't hesitate to ask them. But basically, the problem that we had is that the difference between data engineer and data scientist, in our case, we're external people, so we don't have as much insight on the data as the data scientists do. So the issue that we had is that for a data pipeline to create some insight, the data scientist would have to go back and forth with the data engineer to create his pipeline, which was not really efficient. So what we wanted to set up is actually a small framework that data scientists can use so that they can create their pipeline without the help of a data engineer. So basically, what is our solution? It's an easy CLI tool that was written in Python. In the framework, you also have a file generator, so that will generate all the different files that are needed for a best practice data engineer pipeline without that the data scientists have to actually touch that file. And also a framework around it with like testing so that we know the pipeline will work when it's going to be put into production. So basically, the idea is that then the data scientist can focus on the business logic on how to transform the data and doesn't have to do all the different steps. So to give you more explanation on how we created that, I will explain a little bit how it works in our data lake. So basically, we start from internal VRT sources. So all those different data in different database. The first step is to actually put the data into what we call the raw layer of the data lake. So that is still the work of a data engineer, because basically here you have to be able to play with different technologies, different file format, and ingest them into the data lake. So to give you some example, this is some of the tools we work with at VRT. Some of those are cloud-based, like RDS is the relational database in AWS. And then some are actually on-premise database that the VRT has that we also have to ingest into the data lake. So that's the first step. That's still the data engineer's role to create that pipeline. Then after that, we go from raw to clean. So basically that is still also the data engineer work, where he has to format basically all the data into one file format, which is Parquet. Also, this is where we rename the columns so that they all make sense in the clean layer. And also where we fix the data types to make sure that when the data scientist will use the data, when he queries a string, it will be a string in the data and not something else. So that is all part of what a data engineer should do. And then where we can actually separate the job is in the last step, which is going from clean to derived. So basically then that's where the data scientist can actually work without our help, so that he can create derived data. Basically, what is derived data? It's actually a join of different sources that are in the clean layer and add some business logic, often with SQL on top of that, and then can visualize that data or use it as input in a machine learning model, for instance. So to be more practical, I'm going to give you a small example to the presentation, and then I will do a demo with the same idea as here in the example. So let's imagine here in the context of VRT, we want to know the average age of viewers per show. So we will have a list. We will have a list of user info with an ID, a name, an age, a city, for example, and then show info with like a show ID, the name of the show, and actually the user ID that has watched that show previously. And we want to combine that data to get the average age of the viewers. So to give you a quick example with what the pipeline should look like, basically in row here, this will be CSV. So let's say we ingest that CSV data from the show department. So there's just some data example. Then we move this to the clean layer where it's in Parquet. So basically, Parquet is a column-based format which enable a lot of compression, which is really useful in the case of data lake, especially if you work with big data. Then we merge that user info and show info together to create the derived data that we want. So the goal of the framework is to actually be able to enable the whole logic into, for example, just a SQL statement. So the data scientist will have just to focus on that SQL statement, and the rest will be created by the pipeline, and we'll be able to put that to production really easily just by triggering the CI/CD. Just to be more accurate here, of course, the tool has been created around some technologies that we use at VRT. So those are the main technology that we use. So of course, this tool is not enabled to work in all cases in all cloud-based, but here for this environment, it will work. Yeah, so basically now I will just show you how you can really easily create a pipeline and deploy it to production. So here, what I'm gonna do simply, I'm just gonna create a branch from where we can then merge that to master to put it in production. So let's just call it root lab demo. And so basically the whole tool is based on a config file. So I will show you here, if I go into J. So here we see we have a derived folder with config in there, and basically everything will be based on that config file. So let's create this config file here in our case. So let's call it user show info.json. Okay, so this is what it will look like. So let's go through it so that I can explain a little bit what's in that config file. So basically just a name for the pipeline, a derived type, which means how often this pipeline would actually be triggered. So this is batch cron. So basically it's it's decided by a cron expression, and batch, because this is batch data, we only do it once a day, for instance. The Python Data Lake helper version is basically a small library that we created for the data scientist to use. And you can use a certain version. If maybe there was an issue, you can roll back to the previous version to actually get it to work. So here the cron expression is 5 after 10 every morning. So this is when the pipeline will be triggered. And what we have here is just the list of data that we're going to read, and then where are we going to write the result of our pipeline. So I will quickly show you. So this is the step where the data engineer should have put the data in the clean layer. So I already did that for the demo purpose. So I can show you. I don't know if you are familiar with Athena, but it's a SQL query engine that you can use in AWS to query your data in the data lake. So here I can show you, okay. I can show you what the show info looks like. So this is just some examples. So there is a user ID, a show ID, and a show name. So basically we can see that Big Bang has been watched by user 1, 2, 3, how I met, so I changed the name for copyright purposes. So this is what the show info looks like, and then the user info will just be some info about the user, so just a name, an age, and where the user is located. So this is basically those two sources, and then this is where we're going to output the actual derived data. Also, we're using Spark to process the data. So we use what we call a Spark submit file with configuration to run your Spark job. And then we also have an ingestion checker, which is going to check that the data was actually outputted at the correct place at the correct time. And this will run, of course, after the pipeline. Otherwise, it's going to fail every time. So from there, what I can do, so I can just make sure I have the latest version of the tool. So here, I can just, it's just a Python package, so I can just install it like this. And then I can generate all the files I need to start working on my pipeline. So what I can do add derived. And then I just have to put the config file that I've created. And this will generate automatically all the files that we need to start working on the pipeline. So now I can show you here in the derived folder. Now this folder was created, user show info, with all different files in there. I will explain what those files are made for. But basically now we can start working on the actual pipeline and start creating the logic. So what I'm gonna do, I'm gonna show you this through Sagemaker. So I'm gonna commit this. Okay. Okay, I'm gonna push this. I have to create the branch first. Okay, so now I can go on Sagemaker, which is basically a managed Jupyter notebook that you can use in AWS. And from here, what I'm gonna do, I'm gonna pull my changes. So I'm gonna open a terminal. I'm gonna go into, okay. So here I'm fetching the push that I just, sorry, now I need to go on master. Okay, and now I can check out to my branch. Okay, so make sure I'm up to date. Okay, so from here, I can go into my folder here in data lake, and then in derived, I can see my new directory that I just created with the tool. And then from there, I have a Sagemaker folder where there is a templated notebook in there, which will explain how to actually create the pipeline. So basically what I have to do now is to actually change the logic of my pipeline. So here I can see in Sage, in the folder, I can see user show info job. And this is basically the framework that we created. We divided this into 3 functions: the reader, the transformer, and the writer. So I will open those 3 files, and I will explain what they do. So there is a default file in there that I'm going to change. So I'm going to put this. So basically in here in this file, we can see that what we do is this is where we're going to load all the data that we need to create the derived data. So here I'm going to read the user and show info that I showed you to Athena, and I'm going to attach them to a variable name in Python. So this is my reader. And then my transformer is actually where I'm going to put the logic. So is what it's going to look like. Okay. So basically in here, I'm going to read the user and show info that I've loaded in the reader. I'm going to create a temporary view of this so that I can run some SQL on it. So we can see that here, the SQL is the same that I showed in the slide. It's basically get the show name and the average user age as user age, not name. And this is done doing a join of the 2 tables based on the user ID that are both in the show and in the user. So I'm going to save this, and this is the outputted data frame that I'm gonna then transfer to my writer. So here in the writer, this is what the writer will look like. So basically, we read the transformed data from the transformer, and then we write it with those parameters. So repartition 1 just means that I'm going to only output 1 Parquet file, because by default, Spark will create different Parquet files. And then I can tell where I want to write it in my data lake, and also to what table I want to write to be able to query the data to Athena later. So basically, after those changes, now I can just push this. So push it. So now that it's pushed, what I'm going to do, it's actually, you can just follow in the notebook. This says that you have to run this command, which will actually build the artifact that contains the logic. So now I can run this in the terminal still. So this is actually building the artifact and put it into S3 so that I can fetch it in my notebook. So now if I go into my notebook here, this first line here decides how I want to use my cluster, and also fetches that file that was just built to the command I did. So by doing this, I'm actually loading the artifacts, and then I can run. Actually, this is just a template file which will actually run my my pipeline. So this might take just a little bit of time. But basically, yeah, here we can see the 3 steps. So it reads, it do the reader, the transformer, and the writer, and then so this just defines the function in my notebook, and then by running the last line here, I'm actually gonna run that, and I should see the derived data created in my data lake. So let's hope the cluster is not too busy. Okay, so now it's actually running the pipeline. Okay, great. Oh, yeah, I know why. So basically, yeah, I've already created the table before. So now it's just saying that it doesn't have delete table exception, but what it will looks like is that here, if I synchronize this, I will have the user show info show here, and I can actually then just visualize my data through Athena. So here we have the name of the shows and the average age of the user here in the column. So basically after this, you can just run a pipeline in the CI/CD, and this will export everything into production. And actually we use Airflow to manage our workflows. So yeah, can't show you because I'm not connected, but basically through Airflow, this will be automatically triggered at the cron that we've defined in the configuration. So yeah, basically that ends the demo. So if there are any questions, don't hesitate. Sam?
Sorry, I was still muted. Yeah, I see some questions in the chat. So one of them is from Wim. ABS recently released a managed airflow. So are you using that in the project?
Yeah, so we just found out about that as well. Yeah, that's really recent. So for now, no, because our setup is already created on ECS. So we have a container, managed container running to a managed cluster on ECS. That's the way we run Airflow. So, but we might want to move that to the managed Airflow indeed that AWS just released indeed.
Right. And then a question from Fabrizio. You're also working with AWS Glue in this project? I think it was just a yes or no question.
Yeah, so basically we kind of moved away from Glue. So there is still an integration between Athena and Glue for the table registration, but we don't use GlueJob, for instance, because those are pretty expensive. So we run all our pipeline through a cluster that we manage ourselves, and we run Spark on it. So rather than using the managed version of AWS, we run our cluster ourselves.
Yeah, right. And a question from Gauthier. He asks if this Airflow setup is cheaper than the managed one. If you maybe.
Yeah, I don't know, to be honest. We haven't looked into what the managed Airflow offers, so I'm not sure what the price will be. but I know that the setup that we have to ECS is really cheap because we use Spot instance on a managed cluster, so it really doesn't cost a lot.
Yeah, yeah, and I know that managed airflow one is quite expensive. Nicolas confirms as well. And then a question from Bob. He asks why so the data lake is built with S3 with Parquet files, and it's filled with Spark. He asks why you went that way instead of using something like Snowflake to ingest the raw data and then dbt to make the transformations.
That's a good question. I don't think we've looked into Snowflake yet. I have the feeling. I know Nicholas is actually looking into that for now. So that might be a solution. But basically what we wanted to go with was serverless. So we started with the glue job and then realized this was really expensive. So we kind of decided to manage it ourselves. And yeah, that's for now. That's how we're working, but we're always trying to work more efficiently. So if Snowflake is a cheaper and more efficient solution that integrates well with AWS, that might be a way to go as well.
Yeah, so it might be something for the future. I think that's it for the questions. Thank you for the great session. The session was recorded and will be available on DataRoot's YouTube channel. And make sure to join our meetup group so that you can get notifications when we announce future sessions. You can also follow us on LinkedIn where we announce them as well. Thank you everyone for attending, and hopefully see you next time. Bye.
Thank you. Bye.